In order to be able to solve quadratic equations by square rooting, you need to know how to handle radicals. So let's go ahead and review some radicals. So let's simplify these. So there's a couple of different ways that you can simplify radicals. Some of the easiest ways is to look at the radical and think, what two numbers can I multiply together? One which is a perfect square and have it equal the number that's under there. So if we think about that, well, 4 is a perfect square, so 4 times 10 equals 40. So I can break this down to the square root of 4 times the square root of 10. I know the square root of 4 is 2, so I know that this simplifies down to 2 times the square root of 10. Let's try 54. Well, let's think. 9 times 5 is 45. 9 times 6 would be 54. So I can break this down to the square root of 9 times the square root of 6. The square root of 9 is 3. So this would be 3 square root of 6. So let's try this one now. I'm going to ignore the 3 out front for just a minute, and I'm going to simplify the 75. So I know 25 times 3 would equal 75. So I'm going to just keep the 3 out front for a minute. So I've got the square root of 25 times the square root of 3. The square root of 25 is 5. So I have 3 times 5 times 3, but 3 times 5 is 15. So now I've simplified that radical. Why don't you put the video on pause and see if you remember how to do these. All right, so the first one again is very similar to the one we just did. 75 would be 25 times 3. Square root of 25 is 5. 2 times 5 is 10, so you get 10 square root of 3. On the second one here, number 2, if you remember, you're going to multiply the numbers outside. So I can multiply the 3 by the 2, and that'll give me a 6. And then I can multiply the square root of 10 times the square root of 5, and that'll give me the square root of 50. Well, that's great, except that 50 is not simplified yet. So I could break this down to 6. I'm just going to leave that outside. This could be the square root of 25 times the square root of 2. But I know that the square root of 25 is 5. But I still have to multiply the 6 out here. So this will become 30 times the square root of 2. And over here on number 3, if you remember, I cannot have a radical in the denominator, but I can also simplify this radical. So I like to do that first. So I'm going to say, keep this 8 kind of in the numerator where it is, and I will break this down to the square root of 4 times the square root of 3, because that still will be 12. The square root of 4 is 2, so I'm going to have 8 over 2 square root of 3. Well, I'm going to look at just the numbers. 8 over 2 would be 4. So now I have, this is 4 over the square root of 3. But then there's a rule in math that I can't have a radical in the denominator. So I'm going to multiply the numerator and the denominator by the square root of 3 over the square root of 3. If I multiply across, I'm going to have 4 square root of 3. Oops, I'm stuck here, sorry. 4 times the square root of 3. And remember, the square root of 3 times the square root of 3 is the square root of 9, but the square root of 9 is simply 3. So my answer is 4/3 times the square root of 3. All right, again, why don't you put these on pause and see how you do. Well, here I have a choice. I could simplify the square root of 8 if I wanted to, but I could also multiply them together. It doesn't really matter. I tend to, if the numbers are small, I tend to multiply them together first. But if the numbers are big, I tend to simplify them first. So here I would have the square root of 48, but I can break that down to 16 times 3, which would simplify to 4 times the square root of 3. Again, this one here would be 6 times the square root of 50, but I can simplify the square root of 50 into 25 and 2, so I get 30 times the square root of 2. All right, here's some more. Why don't you see how you do on these? All right, so on the first one, the square root of 25 over the square root of 4, that can simplify down to 5 over 2. The second one will simplify down to the square root of 10 over 4. And the third one to 4 square root of 2 over 3. Let's take a closer look at these. So when I have the square root of 25 over 4, I can break that down into a square root in the numerator and a square root in the denominator. And because they're both perfect squares, you can see that this helps us. I can just say this is 5 over 2. On the second one here, I can actually simplify this square root of 8 in the denominator. So I can really rewrite this as the square root of 5 all over 2 times the square root of 2. And you can see by doing that, the 2 out here I'm perfectly happy with. It's just the square root of 2 that is a radical in the denominator. So all I really have to do is multiply the top and the bottom by the square root of 2. So let's go ahead and do that. So I'm going to multiply by the square root of 2 over the square root of 2. So I'll get the square root of 10 over 16. Again, just like in the previous example, I can break that down to the square root of 10 over the square root of 16. But the square root of 16 is 4. And on the next one here, again, I've got the square root of 18 in the denominator. Let's go ahead and simplify that. It can simplify down to the square root of 9 times the square root of 2, but the square root of 9 is 3. So I just need to multiply the numerator and the denominator by the square root of 2 to rationalize that denominator. When I do that, I will get 8 square root of 2 all over 6. And if I can simplify both of these numbers, if both of these numbers here can be simplified, then I must simplify them. So therefore, I'm going to have 4 square root of 2 over 3. So the product property rule says that if I have a radical underneath, a product underneath a radical, I can break it up into 2 separate terms. And that works as long as they are real. And please keep this in mind, because the next chapter we're going to talk about imaginary numbers, and then this will no longer be true. So remember, I said this is only true for real numbers. The quotient rule, same thing. I can have one radical over the whole fraction, or I can break that up into 2 separate pieces, a radical in the numerator and a radical in the denominator. But this also is only true if the radicals are real. So please keep that in mind, because this will come up again very shortly, and you'll want to do this, but you won't be able to because the radicals won't be real. All right, so now we're getting to solving by square rooting, which we'll take on in another video.